right? The last thing we're going to look at this lesson is dividing radicals, okay? And so another thing about the radical is you're not allowed to have a radical in the denominator. Now, b is an interesting situation because we have the square root of 20 divided by 3. The quotient property of square roots right there says that you could do, actually, that's not the quotient properties up here, I apologize. Is the square root, if you have a square root of a fraction, it's equal to the square of the top divided by the square root of the bottom, okay? Now, here's the thing. If you just have one term on the bottom, here just a square root of 3, they call this a monomial, one term. What you do is you multiply the top and the bottom by the square root that's on the bottom, okay? So you multiply the top and bottom, and you're allowed to do that because whatever you do to the top, you do to the bottom. And that's basically multiplying it by 1 because square root of 3 times or divided by square root of 3 is just 1. Any quantity divided by itself would be 1. So now I'm going to multiply across square root of 20 times square root of 3, square root of 60. On the bottom, I have square root of 3 times square root of 3, which is square root of 9, which is 3. So this becomes 3. So now the square root cancels on the bottom. So that was my mission there. But I'm not done yet because I have to simplify now. So I'm going to break down the square root of 60 because square root of 60 could still simplify. That'd be 2 and 30, 2 and 15, 3 and 5. Okay, so do I have any pairs in there? I have a pair of 2's. So 2 comes out. What stays in? 3 times 5, 15 stays in there. And then 3 on the bottom. Now, I can't simplify these because these are unlike, but I can look at those and see, does that simplify 2 over 3? That's already a reduced fraction. So that's my solution there. Okay. Now, that's whenever you have a monomial, one term on the bottom. What if you have a binomial on the bottom, 2 terms? So what can you do when you have 2 terms? What can I multiply the top and bottom by to get rid of the radical on the bottom? Well, let's kind of think back to this. I can multiply by the conjugate. We learned up here on F, if I multiply by the conjugate, it will allow the radicals to go away. So what's the conjugate of 4 minus the square root of 2? 4 plus the square root of 2. Whatever I do the bottom, I got to do the top. This one gets a little messy, but we'll get there though. Just tedious. It's not hard, it's just tedious. 2 times 4 is 8, so now I've got to distribute. Plus 2 square root of 2 plus 4 square root of 2. Square root of 2 times square root of 2 plus 2. Okay. So now I'm going to simplify this. 8 plus 2 is 10. 2 square root of 2 plus 4 square root of 2 is 6 square root of 2. So 10 plus 6 square root of 2 is going to be my top. Okay. Now let's look at the bottom. 4 times 4 is 16. 4 times square root of 2 be 4 square root of 2. Negative square root of 2 times 4 be minus 4 square root of 2. Negative square root of 2 times square root of 2 would be minus 2. Okay, now look what happens here. 4 square root of 2 minus 4 square root of 2, that cancels. 16 minus 2 is 14. Now there's a little bit of an issue here because each of these terms here, this is not a common term, but these 3 all have a factor of 2. So I could reduce this. So I could divide each of those by 2. So 5 plus 3 square root of 2 divided by 7. And that gives me the solution.